All right, guys. What did I just say this was? Worksheet 16A, it's gonna be maybe? I'll get there. We are solving rational equations today, okay? We have been doing rational expressions where we had to factor and then either cancel because it was multiply or flip one over, divide. Or in this class, we already did the ones where you had to get a common denominator, right? But now a rational expression is different from a rational equation because a rational equation can be solved. What we are going to do is multiply through by the least common denominator to get rid of all the denominators, okay? There will be possible extraneous solutions today. Now, normally when we had extraneous solutions when we were doing these crazy problems, remember? Something like that, which this probably has no solution. I'm positive it does. When we were doing those, we had to put the answers back in to check them to find extraneous solutions. Today, it's going to be a little bit easier. You should put the answer back in and check it, but they're very complicated to check. The thing today is an extraneous solution will be one that makes the denominator 0. In other words, if this was the start of a question, if we blah, 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 if at the end of this problem we got x equals -4, we would get to throw that out because it would make that 0. Does everybody see what I'm saying? Extraneous solution today is just going to be one that makes the denominator 0. Then we're going to know we need to throw it out. Okay. You don't have these. This is just a reminder. Do you remember at the beginning of the year we did these? What would you multiply through by here to get rid of all the fractions? This was the first day or two of class. 56 would work. And then you would multiply 56 onto both sides by each term. So 56 times x, then 56 times 4 divided by 7, and you would type it in your calculator. And then 56 times 3 divided by 2, and that one has an x. Can anybody do that for me? Let's see, 28 times 3. What's 56 times 3 divided by 2? Thank you. And then over here, 56 multiplied by 3 over 56 is just 3. All right. So by multiplying through by the common denominator, we got rid of all of the fractions and it became a much easier equation. I'm not even going to bother to solve, but are we okay with what that did? What is the denominator we would want to multiply by over here? Yeah, the only denominators, 2, 1, and 8, the common denominator would be 8. So 8 times 9 divided by 2 would be 36, and that would have an n right here. 8 times 3n would be 24n. And over here, 8 times 15 divided by 8 would be 15. So we got rid of all the fractions by multiplying by the common denominator. So that is what we're going to do, but these are going to have some crazy algebraic common denominators. In other words, they're going to have x's in them. This first example said we had x minus 8 over x minus 4 equals 11. What is the common denominator here? This has no denominator other than 1 and nor this. So the only denominator is x minus 4. Everybody see that? Anybody awake out there? So I'm actually going to move this. All right, I'm going to multiply this by an x minus 4, and this by an x minus 4, and this by an x minus 4. This is already done for you, so you can just watch my example here. x squared minus 4x. Now here, this will divide out, so I just end up with that 8. And over here, I need to distribute this and get 11x minus 44. If I move, there's an x squared, so I'm going to need to factor. So if I subtract the 11x's over here and add the 44, I hope I'm getting the same thing they did. I got an x squared minus 15x plus, I don't know, 32 maybe? Negative 8 plus 44. Factors of 32 that make 15. Did I do something wrong, guys? What does their work say? Oh, did I lose the problem? Oh, that's another example. They didn't finish this one. Okay. Did someone say they had factors that were going to help me here? Oh, this is 36. Okay, thank you. Then it needs to be 2 negatives. $12 and 3, right? Whew, that took me a minute. So then when I set it, each of those factors equal to 0, I would get 12 or 3. Do either of those make the denominator 0? Remember, the only denominator here was x minus 4, and they both work, right? So both of these would work. Now, if you went back and plugged them in at the beginning, it's very time consuming. You would have 12 minus 8 over 12 minus 4 would be 8. Does that seem okay? 12 minus 1 equals 11. Okay. If you put the 3 back in, you'd have 3 minus 8 over 3 minus 4 would be negative 1. And 8, this is negative 1 down here, so this become plus, so we'd get 11 equals 11. So both of those check, but it's very time consuming to check these. So generally, as long as it does not make the denominator 0, you're good. Here's another one multiplied out. I'm going to skip this one for time's sake and get started on the ones we have. What is the only denominator here? M. So we need to multiply through by an M. Now, we could subtract the 8 over to this side first. What do you want to do here, guys? Anybody care? I'm just going to leave it as it's written then. We have a 15 over m minus an m plus 8 equals 10. And we're going to multiply all the way through to each term by the denominator of m. Now, why was that helpful? Well, right here on this very first term, these m's will cancel, so I no longer have any denominators. So I have 15, m times m is m squared, and plus 8m equals 10m. Now, I really hate when the m squared is negative, so I think I'm going to move everything to the other side. So I'm going to subtract 8m's. I'm going to subtract 15 over here, and I'm going to add the m squared. So I'm going to have an m squared plus 2m's minus 15, which will factors of 15 that make 2, guys. Plus 5 and minus 3 would give me a positive 2m in the middle. I'd have 5m minus 3m would be 2m in the middle. And then I need to set each of those equal to 0. I get negative 5. and 3, and you certainly don't have to show those steps if you get that part. Okay. Neither of those would make the denominator 0. What is the only exclusion here, guys? M cannot equal 0 because it was the only thing in the denominator at the beginning of the problem. Now, I could go through and prove to you that those both work. Okay. If I put in a -5, I'd have -3. This would become +5. -3 plus 5 would be 2. 2 plus 8 is 10. If I put in a 3, I'd have 5 minus 3, which is 2. 2 plus 8 is 10. So they both work. All right. This is more like what the quiz is going to look like. Now, the common denominator here needs both factors, b and b minus 3. Okay? So we're going to have to multiply everything on both sides by both a plain old b and a b minus 3. So I'm going to do that to this first term. And then I'm going to do that to the second term. And then I'm going to do that to the other side. All right. I know it's a lot of writing, and eventually you can probably figure out how to write less by showing less work, but I'm just trying to make you understand that why the denominator is disappearing. So over here on this term, a b minus 3 and a b minus 3 would divide out. So what's left is a 4b. This is worksheet 16, Riley, of Unit 2 packet. I'm sorry, it's way at the back. Did you find it? I should have, as soon as you came in, I should have told you where that was. What cancels on this term, guys? Just the plain old b, but we have a 3 we need to distribute through there, right? I'm going to do that as I write it down. So I'll get a 3b minus 9. And then on the right-hand side, the b minus 3 divides out, and I have a b times a negative 2b, so I get a negative 2b squared. All right, I just mentioned I don't like when those squared terms are negative, so I'm going to add it over to this side because I got to make it equal to 0 anyway. Now I have a 2b squared. I can add these b's together, so I get a plus 7b and a minus 9 at the back. Anybody catch me making a mistake anywhere? All right. You want to try 9 and, I think it's going to be a 9 and a 1, actually. If we put the 9 here and the 1 here, then we'll have 9 b's. And if we make this a negative, we'll have on this a negative 2b, which would give us the 7b in the middle. Does that work, guys? So that was a little tricky factoring exercise there. Now be careful because we have to set this equal to 0 and this one equal to 0. That's how you solve a quadratic once we've factored. Each piece has to equal 0. This one is going to become negative 9/2. Everybody okay? I didn't show all my steps, but any questions on those? Either one of those make the denominator 0. What are the two things we can't have because of this and this in the denominator? B cannot be 0 or 3, right? And we didn't get either of those. So, whoops. Therefore, both of these answers should be good to go. All right. Oh. So for number 3, we have a 2 over a y plus 2. And at the back here, we have a y squared plus 4 that does not factor. And the denominator, how do you factor a y squared minus 4, guys? Yes, we have a y plus 2 and a y minus 2. Whoops. I didn't write that. So, anybody know what we can do with this guy? I really want our common denominator to be y plus 2 and y minus 2. Does that seem okay? What could we do to change this to a y minus 2? Yeah, if we multiplied it by a -1 top and bottom, this would become a -2 and a +1 and a plus y, and then that's allowed. So what's going to happen to the top? Instead of minus -1y, can we just write that as plus y? All right, that's allowed. You can multiply top and bottom by -1, change the signs. Okay, now this is our new problem. And what is the common denominator we're going to multiply each term by? Both a y plus 2 and a y minus 2. And I'm thinking some of you are already figuring out how to write these down with less work. So what's going to divide out of the first term is the y plus 2. So what will be left is a 2 times that we came, 2 that came with a fraction times the y minus 2 that didn't divide out. We change this to plus y when we change the signs in the denominator. So we have a plus y times, now the y minus 2 will divide out. So we have a y plus 2 to distribute into. And on the right, everything divides out, both factors of the denominator, so we just end up with the numerator y squared plus 4. All right, so if we do some distributing, so this started out looking really ugly, but what happens now? We don't end up with a factoring problem at all, do we? Because the y squared can be subtracted off each side. So now I have 4y, I could subtract, well, actually I don't want to do that. I'm going to add 4 over to the other side. So I get 4y equals 8 because I don't have a squared anymore. So I get y equals 2. Anybody's little alarm going off? Can y be 2? No, y would make this denominator 0. Actually, both this one and this one. So y equals 2 does not work. Okay, so I'm going to write here just so we knew. Y could not equal 2 or, that doesn't say 2, Hofbauer. Y was not allowed to be 2 or -2. So therefore, this does not work. This is extraneous. And we have no solution for this one. Sometimes we'll get 2 solutions at the end and one of them doesn't work. This time we only got 1 solution at the end and it doesn't work. So no solution, which is always frustrating because you've done all this work and there was nothing that worked. All right. Common denominator here? Yeah, x and x plus 3. All right. Can anybody tell me what remains after we simplify? What do we need to do here? Distribute a 60 through an x plus 3. So I got a 60x plus 180. That's a big number. Sounds like I'm in geometry. The x plus 3's cancel here. So I just have a minus 60x. Oh, that's handy. And over here, I do have to distribute a 1x through here, so I get an x squared plus 3x. So these were like terms. So what should I do next? Subtract the 180 over to the other side. So I end up with x squared plus 3x minus 180. It seems really big, but can somebody check? I think 15 and 12 maybe are factors there. I know that would have taken some of you a while to figure out, but x plus 15 and x minus 12 is how that factors to give us a negative 180, and 15x minus 12x will give us the 3x in the middle. So if we set this factor equal, we get negative 15. If we set this factor equal, we get 12. And either of those extraneous? Nope. The only thing x can't be is 0 or negative 3, so these should both work. We'll try this one on your own. What is the common denominator this time? 4 and an x plus 3. I'm going to try to show a little less work. So if I multiplied here, ugh, that's really gross, isn't it, guys? Only the x divides out. So we have a 4 and an x plus 3 times an x plus 3. Oh. Here we'd have a 7x times a 4x. Here we'd have a 23x times an x plus 3. Oh, I feel like this is trickier than anything I'm going to ask. Can I just kind of go fast? If you foiled that part together, you'd get an x squared plus 3x plus 3x plus 9. And then you'd still have that 4 to distribute. And I think I will add these and get a 6x in the middle. So I'd have a 4x squared plus 24x plus 36. This term right here would just be a 28x squared. And over here, I have 23x squared plus 69x. I think I just should have said skip this problem, huh? So 4x squared and 28x squared. I think I'll subtract this over here. You can just feel free to just cross this out and not write all this down if you want. I think I have 9x squareds. Is that negative 45x? Oh, look what happens. What can I take out of all of those, guys? A 9. Well, that'll make the numbers a little better. Can 9 equal 0? No, so that isn't a factor. This would factor -4 and -1. So I get x equals 4 or 1. Either one of those garbage? There was a 4 down here, but that's not an x, right? So I think we're okay. The two solutions would be 4 and 1. I should have just had you skip that one altogether. Gross. All right. This looks equally gross, but I don't think it's as bad. I think if we factor this, this is an x minus 6 and an x plus 3. Minus. I guess I'm going to leave the top the way it's written. And there's an x plus 3 down here. All right, and this side has an x plus 2, and that same thing factors x minus 6, x plus 3. So tell me what the common denominator is, guys. X minus 6 and x plus 3. X minus 6 and x plus 3. X minus 6 and x plus 3. So over here, all of this will divide out, and I'm left with what? The 1, okay? Here the x plus 3 will divide out. Oh, I'm left with a 2x minus 4 times an x minus 6 and a negative that I got to distribute at some point. That's what would kill me if I was doing this on a test. I would mess up that negative, I'm sure. All of this will cancel, and I have left an x plus 2 on this side. I almost want to change the signs or something. Anyway, 1 minus, and I'm going to just FOIL this together and leave the minus out there, I guess. 2x times x would be 2x squared. 2x times a negative 6 will be negative 12x. Negative 4 times x will be negative 4x. Negative 4 times negative 6 is plus 24. Oh, I'm going to add these two together. And then I'm going to distribute the negatives. I'm going to have 1 minus 2x squared. This was a negative 16x, which I'm now multiplying by a negative 1. And then I'm multiplying the negative 1 to the 24 back here. So this side has a negative 2x squared, a 16x, and a negative 23 when I combine like terms. Okay, thinking we should have skipped this one too. I'm going to move everything to the right because, again, I want that 2x squared to be positive, so I'm adding it over there. I'm subtracting 16x's from the one that was there, so that's a negative 15x. And adding 23 over there is 25. Okay, I have a 2x and an x. 5 and 5? I don't know a lot of other factors for 25, right? I think that actually works because this is a negative 5x and this is a negative 10x, which should give us the negative 15 in the middle. So what do we get out of that disaster, guys? 2x minus 5 equals 0 would be 2x equals 5 or 5 halves. And the other one, x minus 5 equals 0, would be x equals 5. Either of those garbage or extraneous? No? I will not ask one like that, I promise. So I should have just skipped that in the video. Told you to skip it. This does look a lot like something that's on the quiz, I think. So I'm going to do this one. 3 over, I'm going to take out an x. Okay, what's the common denominator? We got this, guys. X and x minus 4. X and x minus 4. X and x minus 4. So what happens here? What am I left with? I like this question. Finally one. What's left on that side? 3. What's left here? 1. What's left here? 1 times x minus 4 is just, okay. So I have 3 equals, be careful, 1 minus 4 is negative 3. So if I add 3, I got 6. Did anybody else get 6? I like that question. Keep in that one, okay? That's a good one. Okay. Is that all I have? I thought I put a... Okay. So what's your assignment? And why is it not on my slide? Yeah, it says to do 17A. It says at the top, do 2, 3, 4, 6, and 7. Okay? Do 2, 3, 4, 6, and 7. And then it says look over the review, but I didn't even give out the review yet, did I? Okay, so I should move that to tomorrow. Well, not in the middle of that sentence, I shouldn't move it. Okay. I don't know why I'm still recording.